SAD chest 2 is going to follow SAD chest 1. In chest 1, we prescribe to the isocenter. In chest 2, we're prescribing to a spine calc point. In order to have a uniform dose distribution delivered to a calc point that's not at isocenter, specifically one that's closer to the posterior and further from the anterior, we have to have unequal beam weightings. So we're going to calculate both of these fields monitor units that have unequal beam weightings in order to have a symmetric dose distribution. So I'm still delivering 250 centigrade times 15 to 3750. I'm normalized at 100% isodose line, and I'm prescribed to my spine calc point. My monitor unit equation doesn't change from the previous example. We are making some assumptions. We are assuming that I have a 10 centimeter equivalent square, which is a rough approximation suitable for this example. We do have some curvature of the patient as well that's going to affect dose distribution, but for the most part, this should get us pretty close. So if I take a look at the printout for the report, I can see that field 1, I'm delivering 149 monitor units. Field 2, I'm delivering 149 monitor units. This makes sense because I effectively have a symmetric patient, and my isocenter is placed midline, so I want a uniform column of dose, and effectively the fields are mirrored, so in order to deliver a uniform amount of dose to mirrored fields set equidistant from each other, they're going to have the same monitor units or similar monitor units. The primary difference is going to be inverse square factor, a different tissue maximum ratio, and then your different doses that are going to get us there. So my MU equation is going to be dose. I've got collimator scatter factor, phantom scatter factor, my depth component, isodose line inverse square factor, and off-axis factor. So a lot of these kind of drop out because I've conveniently chosen some jaw sizes that get us close to 10. So my dose for my AP, if I look at spine CP or spine calc point, is going to be 92.9. You can zoom in. Centigrade. Notice that I'm not at a 50% beam weighting. If I was at a 50-50 beam weighting, my spine calc point would have half of the dose, so half of 250. And then because of that, my monitor units for each of these beams would be different. But I've weighted the fields unequally. Collimator scatter factor is 1, phantom scatter factor is 1. My tissue maximum ratio, if I pull down here, 10 centimeter field size, and my depth is 14.9, so effectively 15 centimeter depth. So 1510 is 0.635. My isodose line is 1 because I'm prescribed to 100%, and my inverse square factor is source to calibration distance divided by source to point distance. Now my source to point distance is going to be the SSD, which is 89.9, plus my physical depth, 14.9. Remember, my calc point is 5 centimeters posterior to the isocenter. So from the anterior field, it's 5 centimeters away from iso, or roughly 105. I have no off-axis factor since I'm on this central axis ray line coming from the beam's eye view. So if I calculate this, 92.9 divided by 0.635. Okay, times 104.8 times 104.8 divided by 101.5 divided by 101.5 gives me 156. Now I'm delivering 149 from my treatment planning system. So if I take 156 divided by 149, I get a 4.5% error. So I think based on the assumptions that we've made here, that would be acceptable. If I look at the posterior, my PA field, my spine calc point is delivering 157.1. Conceptually, this makes sense. I have equal monitor units. My calc point is closer to the posterior source than the anterior source. My dose from the posterior should go up based on inverse square alone, let alone attenuation from the tissue maximum ratio. So 157.1 is my dose being delivered from that field. My collimator and phantom scatter factors are each going to be 1. My new tissue maximum ratio, now there's a small magnification difference here. So 10 centimeters tissue max ratio at, what was my depth? 5.3. Let's see, 10 centimeters, 5.3 puts me at 0.9. I'm at 100% isodose line. This time my inverse square factor is 101.5, source to calibration distance, ooh, I forgot that, divided by, this time I'm 5 centimeters closer to the source. So if I look at my report, my SSD is 89.8 and my depth is 5.3, so my physical distance from the source is 89.8 plus 5.3, puts me at 95.1 squared. So if I do this math, I get 157.1 divided by 0.9 divided by 101.5, 101.5 times 95.1 puts me at 153.2. My treatment planning system monitor units were 149. So 153 divided by 149 gives me a 2.5% error. So I got 156 from the anterior, 153 from the posterior. And that is going to be a parallel opposed pair calculating the monitor units to a calc point, not at isocenter.